Welcome, everybody. This is John Morales. I'm the Chief Meteorologist for NBC 6, and we are streaming to you via our YouTube channel, youtube.com/NBC6 South Florida, as well as the NBC 6 Facebook page. We're going to be talking about the projections for this 2020 hurricane season. And eventually, as we go through this, really anything you want to ask is fine. It doesn't just have to be about the hurricane season. It can be about hurricanes. It can be about anything you ever wanted to know about weather, but we're afraid to ask. It can be, of course, about the climate crisis or anything along those lines. Now, I'm honored today because I'm going to be introducing our guest from Florida International University. So he helped to found the Florida International University's Atmospheric Sciences program, which has quite a robust group of graduate students as well as a group of undergrads studying meteorology. And that's Dr. Hugh Willoughby. So Hugh, well, he's had a storied career. You're going to see him in just a second. And there he is. And at some point, his mic is going to be unmuted. And I just wanted to say hello. And actually, my first question for Hugh is going to be, Hugh, do you remember when and where we first met?
Well, thank you for having me on the show. I think it was when you were working in the weather office in San Juan. Is that right?
You got that right.
It was way back.
Oh, thanks.
Well,
yeah. So I was working at the National Weather Service Forecast Office in San Juan, Puerto Rico. It's funny because just this week they had that show on PBS on the University of Chicago's very storied career of Dr. Ted Fujita and tornadoes and such. And the gentleman who you remember, Hugh, who was my mentor and encouraged me to study meteorology, also studied at the University of Chicago and was there when Ted Fujita was there, and that's Dr. Jose Colon.
Yes.
But you remember Jose Colon as a meteorologist in charge in San Juan.
Well, I also remember the papers he wrote in the early days at the Hurricane Research Project. So, yeah, he's a famous individual, and you should be honored that he was one of your mentors.
No, I indeed am, and I don't think I would have started down this path if it wasn't for him. Back when I was in high school, I visited the National Weather Service there in San Juan, and just inquired and said, hey, this is a field I'm interested in. Do you think there's any opportunities? And he, of course, was very enthused. And I guess the rest is history. I did spend 7 years with the National Weather Service. And I would like you, Hugh, to tell the folks in the audience, because before being at Florida International, you had a long career as a civil servant as well. And I'd like people to know what it is that you were doing for Noaa or for the CARCA or for the Weather Service.
Well, I have an undergraduate degree in meteorology in geology, and for a variety of reasons, I started studying meteorology at the University of Arizona, and I was fixing to get drafted, so I joined the Navy, and they sent me to the Naval Postgraduate School. And I was a student there when Hurricane Camille hit the Gulf Coast, and they were looking for, shall we say, young officers with more education than judgment. They weren't happy with the performance of their reconnaissance crews. And I raised my hand, and 6 months later, I was on Guam, and I flew typhoon reconnaissance for a couple of years. And then I got out from there. I taught at the Naval Academy, and I came to Miami to get a PhD at university at Rosenstiel School. With an idea of getting a flying job with Noaa, and flew with Noaa for 27 years, became the director for 6 years at the Hurricane Research Division. I didn't particularly enjoy that job. And then I retired from there and started at FIU. I debate whether flying with Noaa or doing hurricane research at FIU was the best job I ever had, but they were both pretty exciting.
Well, I think from the viewer's perspective, I think what they probably find sexiest is your flights with Noaa, because I want the viewers to know that when Dr. Willoughby is talking about flying with Noaa, he means flying into hurricanes in Hurricane Hunter aircraft. Let me ask you maybe your top two. What were your top two experiences that are more memorable experiences in flying into hurricanes?
The high point of my career was Hurricane Allen, because that made firm on a scientific basis this idea of concentric high walls.
Mm-hmm.
And that was, I remember sitting in the weather office in San Juan and saying to Ed Zipser, another towering figure in the history of hurricane research, that, well, it's got a small eye now, but it'll be a big, sloppy, cloudy eye when we get there. And it was so. And that storm in its evolution was the thing that really made my career. The other, of course, is Hurricane Hugo. When we were the first airplane into it, we lost an engine at 1,000 feet in severe turbulence and got into the eye. And there was a lot of debate about, why don't we use up all the fuel, like a half an hour left, and get out of the storm and put it in the water. And that was an interesting adventure. I remember when I got home, I was in the culture of aviators with few words, and I said to my wife, "Gee, you'll probably hear that we had a bad time in the air." It really wasn't clear that we were going to survive. And I remember orbiting in the eye and saying to myself, well, this is what you signed up for. And we did. I was very drunk out that night.
Yeah, to celebrate life like you had never celebrated life.
Like we still have some.
Yeah, so actually, I'll tie this all back together by saying that. So of course, I mean, I do remember Allen. Allen was in 1980. At the time, it set some records for strength and then Hurricane Hugo. So Hugo, which was the first hurricane to make landfall in Puerto Rico. It's since the 1950s, which is kind of hard to believe. Hugo was 1989, Hurricane Hugo. You have to go back to 1959 or 7 for the previous hurricane that had struck the island. So it was an immense novelty in Puerto Rico. I mean, not just an emergency, but a novelty because people hadn't gone through that for an entire generation. So as you said, we met at the National Weather Service in San Juan. I was a journeyman forecaster, meaning I was just forecasting the weather for the general public, for marine interests, for aviation and such. But I also had a knack for communications, right? I mean, I had been a disc jockey at the radio station at my university at Cornell. I was at WVDR as a disc jockey, as a sportscaster. I had an ability to communicate with media. So what happened was that during Hurricane Hugo, I got a ton of media exposure as the de facto spokesperson for the National Weather Service in San Juan. And that included emergency alert broadcasts in English and Spanish. And so after we recovered from the aftermath of the hurricane, I had a news director from the Telemundo station in Puerto Rico approach me and say, hey, you're pretty good at this, communicating weather information. Would you consider a career in television? And while I never did work for the Telemundo Channel 2 station in Puerto Rico, that kind of planted the seed. And eventually another opportunity came up, not in Puerto Rico, but in Miami, for the Univision station for Channel 23. And that's how I started my career in broadcasting in 1991, 7 years after I had started as a civil servant for the National Weather Service. All right, listen, so we're 10 minutes in, and we have yet to discuss what's supposed to be the subject matter of this streaming show today, which is the 2020 hurricane season. So before we go into that, let me put up this graphic to show yesterday's NOAA Climate Center forecast for this hurricane season. And I really, when I look at their forecast, instead of looking at the numbers on the right so much, the number of named storms and hurricanes and major hurricanes, I like to look at the pie chart. I like to look at the pie chart because it tells you in probability what they're thinking the season is going to be like. So they're forecasting a 60% chance that this hurricane season is going to be more active than normal. Normal being 12 storms, out of which 6 become hurricanes. And, if you add that little 10% slice there, there's a 70% chance that it's going to be greater or equal to 12 storms and 6 hurricanes. And you can see what the forecast is. Now, I'll put up the second graphic here because I want people to realize that while NOAA's forecast is the one that garners the most attention, and I think the Colorado State University forecast is the one that gathers the second most attention because it's the legacy forecast. And by the way, if you're looking for it on this complicated chart, which I'm about to explain, it's the first blue on the left. It says CSU on the bottom, and that is their forecast for this hurricane season. And the way you interpret this graph now, you're looking at forecasts from numerous entities. Some are academic, in other words, universities. Some are meteorological centers. Those are in magenta, like the European Center for Medium Range Weather Forecasts, ECMWF. That's the center line there in magenta. And the one on the right is the UK Met Office. They put out a forecast too. The ones in purple or violet are the private or commercial weather entities. And then the universities are the ones in light blue, including quite the hyperactive forecast from Penn State University, which includes as many as 24 tropical storms within that bar that you see there. But if you want to boil it all down, you look at the big orange dot on the left. And the big orange dot on the left is right at 17. And that, just before yesterday's NOAA forecast, 17 is the average of all the different seasonal forecasts that have come out so far for this hurricane season. And folks, 17 is a good 40% more tropical storms than you would see in a normal year. So let's discuss this. Hugh, Dr. Willoughby, can you tell people watching what are some of the underlying reasons why the majority of the seasonal forecasts are calling for a hyperactive Atlantic hurricane season?
Well, they're not really calling for a hyperactive. They're calling for above average. The way I looked, I went back over the last 5-6 years. This forecast it's the same kind of forecast you get for you had last year, the year before, 2017 and 2016. And they were all above average. There was at least one very destructive storm, and conditions were the same. Warm tropical ocean in the Atlantic and neutral or a weak La Nina in the Pacific. So I think we're going to, forecasting persistence really, we're going to see about the same kind of season we saw in those years. If you go back further for 13 through 15, there was an El Nino, and that made it, those years were remarkably suppressed. What they're basing the forecast on is warm water in the Atlantic, in the tropical Atlantic, and neutral or slightly above average temperatures in the Pacific. So we won't have strong shear in the Atlantic, and the warm surface waters will provide plenty of energy. And it's pretty much a pretty straightforward forecast. It'd go wrong if we went either El Nino or a strong either El Nino or La Nina, but they're calling for neutral, sort of towards El Nino, La Nina.
Right.
And there's no reason to doubt it.
Do you think, I mean, so what if instead of staying closer to neutral, we end up with not a strong La Nina, but a normal average La Nina, which is contemplated within the realm of the different long-range forecasts for this late summer and early fall? There are some, there's a good number of models that are indicating that there's a chance for a moderate La Nina.
That'll determine whether it's average or above average or way above average. I don't think that at this stage you're not going to heat up the ocean or cool it down much in the Atlantic, but the Pacific can change, on the course of a month or less.
What about, before I get into sea surface temperatures, well, actually this will be about sea surface temperatures, but before I get into long-term trends of sea surface temperatures, let me talk about something short-term. Because of the coronavirus and the shutting down of the global economy pretty much during a period of time this spring, there's been a significant reduction in aerosols in the atmosphere, pollutants that can block solar radiation. I wonder if you have any thoughts. Do you have any thoughts on increased incoming solar radiation on the short term that might, I guess, add a bit of an accent to the warmth in the tropical Atlantic this summer? I'm
not sure that that's a strong enough effect to produce a change. It'll actually be interesting two ways. The aerosol effect, which will make it warmer, and there may be a reduction in the amount of CO2 going into the atmosphere. The biggest source of carbon dioxide is electric generation. And they're generating electricity for people to use in houses, but they're not generating as much for industrial uses. And in the US, motor transport is the second largest contribution. And people aren't driving. I've filled my car up once since March. And so it's going to be interesting to see if there's a signal and what it does. We'll know at Christmas time.
Well, of course, a lot of the the CO2, the reductions in CO2 that we're seeing are really basically just a drop in an ocean. I mean,
but the little bumps, the annual bump, it'll be interesting to see if that's it'd be interesting to see if that shows a signal.
Yeah, well, we'll see. All right, so let's talk a little bit about some of the multi-decadal natural cycles in the Atlantic. I mean, we know that at times sea surface temperatures and I guess also the depth of the warmth in the upper layers of the ocean tend to be warmer during a certain number of decades, call it 2 to 4 decades in a row, versus other times when they're cooler. and that has to do with an entire conveyor belt of ocean currents. Can you help people understand a little bit about those natural multi-decadal cycles that we see in the Atlantic in terms of sea surface temperatures and therefore hurricane activity?
Yeah. Water in the Atlantic flows northward in all latitudes. Notice I said northward. The water comes in around the southern tip of Africa and it flows northward, even south of the equator, up to the Greenland Sea between Greenland and Iceland. And there it sinks. And now it flows southward as cold, very salty water and goes back into the world ocean and various places, primarily the Pacific and Indian Ocean, comes up to the surface. A given parcel of water may take 1,000 years to complete the cycle, but sometimes it runs faster. When it runs faster, there's less time for evaporation to make the water dense, salty, and it's tending to slow down. When it's going slower, there's more time to make the water dense and salty, and it speeds up. It's not an oscillation; it's a vacillation. There was, let's see, if the years from 1970 to 1969, it went slowly. Since I'm sorry, 1970 to 1995, it went slowly. Then it speeded up since. It looked like it was going to slow down in the early teens, but it didn't. And it's due. But anyway, when the circulation runs fast, the water's warm, more hurricanes. When it runs slowly, the water's cold, less hurricanes.
Yeah.
And we've been in a cycle for 25 years, in an active cycle. And at 25 years, we should start to look for a slowing down. There's a general tendency for the oceans to be warmer. I was reading an article in the Bulletin of the American Meteorological Society where they said more likely than not, global warming is having an influence. But they've got to untangle this multi-decadal cycle from the tendency, and they're not very good at that. And some of the people who study climate change, the effect of climate change on hurricanes, are aliasing the cycle, the cyclic changes into the long-term trend. But I think there's a long-term trend over the 100 years, 120 years now, that we've had the cycle. We see the damage due to hurricanes has increased 1% or 2% above the increase in gross national product. It could be due to the fact that the development is more along the along the coast, but it could also be a climate change effect. But it's subtle, and it's not. It's marginally statistically significant. It's sort of 11% that it could come about by chance. But given that there's theoretical reason to expect that when the ocean gets warmer, hurricanes are more destructive, it certainly is reasonable to believe, but by no means proven.
Right. Well, a paper did come out this week where this is work by Kosen and Knudsen as well. So they have been observing within the satellite era across the globe trends in the intensity of tropical cyclones And while, I mean, you're correct, we haven't seen a trend in terms of the total number of tropical cyclones forming around the world. There's no clear signal as to whether there's going to be more or less. There's many confounding variables in that. There does appear to be, according to this paper published this week, a statistically significant upward trend in the proportion of the tropical cyclones that are forming around the world that are reaching the most destructive categories, category 4 and 5, within the satellite era. So that was just published this week.
Yeah, there are data problems outside the Atlantic. The satellite looking at at storms on the limb and so on. And I don't want to quibble about it, but we should worry about it. There's theoretical reason to believe that the effect would be increasing as you say, increasing the strength of the strongest hurricanes, not necessarily numbers.
Yeah,
and it makes well, we question it, but that'd be a working hypothesis now.
right. So let's see if and I don't know if the moderator is going to show me any questions somewhere. Oh, we do. We have a viewer question, says our moderator. So let's see what they have for us. And I don't know if you can stick around for just a few minutes past 12:30, Dr. Willoughby. Is that possible?
Yeah, sure.
Okay. Let's see. When do I think the forecast will change? In July again. Why don't the forecasts come out every month instead of... Well, so I don't know. I guess you see the question too, right, Dr. Willoughby? Yeah. I'll comment first, and you can add to this. But I mean, seasonal hurricane forecasting is, it's definitely a science. But there's different ways of doing this. You can do it purely based on statistics and analog years, or you can do it dynamically as well by looking at dynamic models as to how the atmosphere is going to behave between now and the fall. And then there's hybrids where you use both the statistical methods and the dynamical methods. We just saw on a chart that I showed you earlier that while there seems to be a consensus for a more active than normal hurricane season, there are a couple of European Met offices, the UK Met Office and the consortium of the European Center for Medium Range Weather Predictions, that are forecasting a not too far from normal season. So they're the two outliers within this group. The forecasts do get adjusted. Colorado State will come up with another forecast coming up in June, and then they'll update that several times heading into the fall based on conditions as they're observed. I think Dr. Willoughby, you early in our interview here mentioned that there are some variables out there that could change. Do we get a neutral ENSO or do we get a La Nina? That's one factor. How do sea surface temperatures continue to vary as we go into the summer? Are there any other variables, Hugh, that we should be that could change?
There were some that they looked at in the early days, the multi-decadal, the quasi-biennial oscillation, winds in the stratosphere blow from the west and from the east, and so on. But really, the sea surface temperature and El Nino are the main ones, and the information for the forecast doesn't change every day. It changes on about the conditions on which the forecast will be based become different on about a monthly time scale. So that's why they come out. They're just a few updates.
Yeah, and I think people need to remember that these are projections for a long period of time. I mean, the Colorado State forecast, their initial forecast comes out in April for a season that runs from June 1st to November 30th. There's bound to be a lot of uncertainty in a forecast of that nature. I think it just, it serves as a guide for what to expect during the year. At the end of the day, all we have to do here in South Florida is go back to 1992 and realize that the very first named storm of 1992 was Hurricane Andrew. And that didn't happen until the middle of the month of August. I mean, heck, we already had the A storm in 2020, and we've had the A storm prior to June 1st each of the last 6 years. Yet in 1992, it was so inactive that the A storm didn't come until the middle of August. And yet it absolutely pummeled South Florida, and everyone that lived through it, it's become an unforgettable experience, and not in a good way. So it doesn't have to be an active year for one hurricane to have a very strong impact upon any one region. We really don't know where these hurricanes will go once they form. Here's hoping for maybe for those weather geeks out there, a negative NAO, so that we have a nice big trough of low pressure along the eastern seaboard of the U.S., serving as a deflector shield so that whatever forms out there will recurve before it reaches Florida. I mean, that'd be great. But we don't know. We don't know yet how the season is going to unfold. I wonder if there's any other questions from the audience, or that I can pull some from my Facebook page. Let's see. And if not, this being 12:32, Dr. Willoughby, I want to thank you for being part of this today, and I want to thank the audience as well for joining us today. Of course, the NBC6 weather team will be there with you through hurricane season, as we always are. And you know my style anyway, and I try to lead our department that way. Just the facts, no hype, and try to keep you calm when you face the emergency. This TV market is certainly one to hype things up whenever they get a chance, and it's always a battle in the newsroom, but we do the best to keep you as calm as possible and deliver the information that you need. Again, thank you everybody for joining us today, and we'll see you on air and online on NBC6.